Section 7.3, Problem 23. A Nielsen company report states that the mean number of TV sets in a U.S. household is 2.24. Assume the standard deviation is 1.2. A sample of 85 households is drawn. So for this problem, we have the mean is 2.24 and the standard deviation is 1.2. So the mean they are talking about in the general the mean, this is the US mean, the US household. So they're talking about population. And we want to take a sample of 85, so n is 85. And we want to find the probability of the sample mean. So we are given the population number and we are taking 85 sample size. Then the question asks us about the sample by the center limit theorem. Because your n is big enough, is more than 30, so the mean of the sample is the same as the population mean, which is 2.24, and the sample standard deviation is sigma divided by square root of n is 1.2 divided square root of 85. This is by center limit theorem that you can find in section 7.3. Now we will input those numbers in the GeoGebra. So the mean for the problem is 2.24 and the standard deviation, I'm gonna click on the fraction first, which is divide, and then on the top I have 1.2. In the bottom I do the square root and the square root of 85. So after you finish input the number for the mean and the standard deviation sample, you want to find the probability that greater than 2. So rather, we need to say greater than 2. So let's draw the picture. So you have 2.24 for the mean. So you have 2 is here. You draw the line. And because the problem say greater than 2, so you draw the line and you shade on the right side. And our job is to find this probability. Okay, so I click on shade on the right, and then we have 2. Then our number is 0.9674. That is the probability number in the probability box, 9674. For part B, we want the sample mean probability is between 2.5 and 3. So 2.2, 2.24 is here, 2.5 and 3 is here. So you draw the line and then you take the probability between them. Okay, so 2.5, so we click on the between, which is the second one when you go from the left to right, and then you do 2.5 and 3. Then we got 0.0229. Problem C, find a 30 percentile. So this is giving us the probability, which is 0.3 for the percentile. And again, every time we have the percentile, it's counting from the smallest number. So right here is above the 50%. So 30% is the estimate is about like this. So this is This is 30% or 0.3. And we want to find out the x value. So basically this problem asking us what is the x value when they're giving us the percent number. Okay, so we put percent 0.30 in the percent box, and we remember to shade the first click. You do the first click for shade on the left side. Your answer is in the parentheses 2.17. We take two decimal places, 2.17. So 2.17. For part D, what it be unusual for the sample mean to be less than 2? So we did greater than 2, but we did not do less than 2. So let's just do less than 2 first. We want to find the probability that less than 2 first. And the probability is 0.0326. Okay, so this is about like 3.3%, and 3.3% is less than 5%. So we will answer that is unusual. For part E, can you tell whether would it be unusual for an individual household to have fewer than 2 TV sets, and explain? So go back to problem D. We have unusual answer for the probability that with a family that has 2 TV or less than 2 TV is unusual, because the percent give very low, it's like 3 point something. And of course, there are some family that have 1 TV, 2 TV sets, 3 TV sets, 4 TV sets, 5 TV sets, and so on. So the probability unusual, we are talking about the probability. And in this problem, they're talking about specifically one family, one household that has a TV set, less than 2 TV set. So we cannot say one household is unusual. The word unusual is just before for the probability. When you pick a family and that family has less than 2 TV is considered to be unusual because the percent is very low. But we cannot say that family is unusual family. Okay, we're just talking about the probability unusual, not the specific family is unusual or not. So can you tell whether it will be unusual? So we said that we cannot tell whether it will be unusual because we have the probability. The word unusual is preferred for probability only.